Hello friends, I'm back with our second lesson for the week, and so today we're going to be looking at circles and the Pythagorean theorem. And so we're going to start off with a little bit of review about some things to remember, some conjectures. The first one is the tangent conjecture, and that tells us, and you already wrote these down, so you don't need to write these down again. You've got them probably already in your notebook or on a little handy sheet that we talked about. The tangent conjecture tells us that a tangent to a circle is blank to the radii drawn to the point of tangency. So we see it right here. And so what that means is that it is perpendicular. And the symbol for that, remember, is that upside down T. And then our second conjecture is angles inscribed in a semicircle conjecture. And what that tells us is that angles inscribed in a semicircle are right angles. Now, we are reviewing these two things because those are very important to what we're going to be practicing today. So we're going to start with our first example. And in this example, you can see we have a circle O here, and it tells me that my given is OC, segment OC is perpendicular to AB. So I'm just going to mark that right there. And AB is 24 centimeters and MC is 8 centimeters, so that means this section right here is 8. And so we want to know what is the diameter of circle O. That's what we're trying to find, the diameter of circle O. So what we're going to start off with is I'm going to, because this section talks about circles and Pythagorean theorem, that makes me think that it's talking about right triangles. And so since I want to know the diameter, that means 2 radii, I'm going to draw a triangle in here. And now I have a right triangle. And so what I'll do is redraw that right triangle a little bit larger. And I know that AB is 24, and this is halfway. And so that means from A to M is 12. And I know that MC is 8. That's not helping me so much just yet. I'm going to put an X here for the measure from M to O. And then AO, this is also a radius of the circle, just like OC. So that means that it has to be whatever this part right here is, OM plus 8. So this must be X plus 8. So we're taking these two sections here, and that would be the same distance there. Now, once I have all this, I can just use Pythagorean theorem. So I can do my legs, x squared plus 12 squared equals, and then now make sure this part goes in parentheses, x plus 8 squared. X squared plus 144. And then for this x plus 8, come down here and do the box if you need to. And you have x squared, you'll have two 8x's. And 64. So x squared plus 16x plus 64. Those x squareds will subtract, and so those are gone. They eliminate each other. And then if I subtract 64, I end up with 80 is equal to 16x. And so x is now equal to 5. Now remember the question said, what is the diameter? And so to find that, remember that's the radius times 2. So to get my diameter, I'm going to have x plus 8 times 2. So 5 plus 8 is 13, times 2 is 26. So my diameter is 26 centimeters. Now again, remember, pause the video at any time if you need a little bit more time or you feel like we're going just a little bit too fast, okay? You especially want to pause it when you're drawing the picture. You want to put these things down in your notebook, okay? Here is our example 2. And for example 2, we have a circle here, and then we have two lines that are tangent to the circle, and we know that from point H to A is 8 times the square root of 3 centimeters. So and then we also know the central angle is 120. So what I'm going to do is divide this. I'll draw a line right there to divide it. And so because this is tangent AH is tangent to circle R, and TH is tangent. That means they both form 90-degree angles. This line right here is going to be a bisector. So now I have a right triangle, so I'm going to redraw that right triangle and label what I know. So we have R, A, H, and then I know HA is 8 times the square root of 3. And because I divided this or bisected this angle, the 120 degrees, that means that angle R is 60 degrees, and so angle H is 30 degrees. Now think about what we remember about 30, 60, 90 triangles. Those special right triangles, that short leg is always X. This would be X. And this would be X times the square root of 3. And this, the hypotenuse would be 2 times X. So if this is 8 times the square root of 3, then that means AR is 8. And HR, which I don't think we need, but we can write it anyway, HR is 16. Okay, so now we've got a little bit more information. AR is also the radius of the circle. So the radius is, now we know, 8 centimeters. Okay, so now, and this part right here is shaded. So what we're trying to find is what is the area of this shaded part. So we can find the area of this triangle and double it because there are 2. And so using what we have over here on our pink triangle, we would have the area is, remember X was 8. 8 times the square root of 3 divided by 2. That gives us 32 times the square root of 3. But we have 2 triangles, so that makes that 64 times the square root of 3. Now we're going to need that. Square centimeters. We're going to need that in a few minutes, okay? Now we need to find the area of this sector right here, because we need to take that out. We've got to take that away. And so to find the area of that sector, we're going to find the area of the circle. And so our radius is 8, so it's going to be 8 squared pi, or 64 pi square centimeters. And we have 120 degrees out of 360. That's 1/3 of the circle. So 1/3 times 64 pi, I'm just going to leave it as 64 pi thirds square centimeters. Now we're going to take the whole entire shape and subtract from it the area of the sector. So we're going to have 64 times the square root of 3 minus 64 pi thirds, all of that centimeters squared. If you work that out, you get approximately 43.8 square centimeters. I have 2 more problems for us to look at. Example 3. At the top, we have circle O. And in our problem, it tells us that OD is 24. So that looks like the radius is 24. And we know that this little angle right in here is 105 degrees. So the first thing I want to do is figure out what's this angle over here. So I'm going to do 360 minus 105 plus, and now I know angle OBY is 90 degrees and ODY is 90 degrees. So if I add all of those up, I get 360 minus 285, which then gives me 75. So angle BOD equals 75 degrees. Now I know, again, my radius is 24, and I want to know what is the area of this shaded part right here. So I'm going to find the area of the whole circle. So it's 24 squared pi, which is 576 pi square centimeters. And then I know if this central angle is 75, then I can do 75 out of 360. There's a couple ways you can do it. Multiply this by 576 pi over 1, and you get 43,200 pi over 360. That equals 120 pi. But that would give us the part that's not shaded, and what we really want is the part that is shaded. We could have subtracted that 75 from 360 and use that here, but we're going to do the subtraction now. And so we're going to take that whole area, 576 pi, subtract from that 120 pi, and we get 456 pi, or approximately 1,433 square centimeters. All right, and we have one more to look at. This is example 4. In this one, we have a circle, and it has a central angle drawn that's at 120 degrees. And then we have a chord here, OH, and it tells me that HO is 8 times the square root of 3. We want to know the area of this shaded part right here. So first thing I'm going to do is I'm going to redraw that triangle. Remember, this whole section is about Pythagorean theorem, right? Triangles and circles. And so if I redraw that triangle, and this was 120, if I divide this now, then that means this is now 60, and this is 30. So now I have a 30, 60, 90 triangle. And I knew that this whole measure here was 8 times the square root of 3. So that means then this part right here is half that, 4 times the square root of 3. So now I've got this triangle, a right triangle, that has 4 times the square root of 3. That's the longer leg. It's opposite the 60-degree angle. And that means that the height of it is 4. And if I needed the hypotenuse, it would be 8. So from here, I can find the area of the triangle, of the whole triangle, or this one. Let's go ahead and do the whole blue one. And so that means it's going to be 8 times the square root of 3 times the height, which was 4, divided by 2. So the area is going to end up being 32 times the square root of 3 over 2, or 16 times the square root of 3 square centimeters. So that's the area of the triangle. And now if I find the area of that sector, I know that 120 out of 360 degrees is 1/3 of my circle. The area of the circle is going to be the radius, which, do we figure out the radius? Let's see. This was OH, and so our radius was going to be from O to the center. If I'm looking here, it's H. There was my center, so that means my radius is 8. We did need that. So the area is going to be 8 squared pi, or 64 pi square centimeters. Now we have to take that and multiply that by 1/3, and we get 64 pi thirds. Now we just subtract. So we are going to subtract 64 pi thirds minus 16 times the square root of 3. All of that is square centimeters, or it is approximately 39.3 square centimeters. So your practice today is worksheet 9.6. I've set it up for you to use Kami. I hope that that works out okay. If you're having trouble accessing that, let me know. You can always just write it out and then take a picture, that's fine too, but I just thought it might be a quicker way, an easier way for you to write right on the worksheet and have the images already drawn for you. All right, remember we have another geometry class check-in chat Thursday from 1 to 1:30, so check out the Zoom login information, the chat joining information on that, okay? And talk to you soon.